Hello there. Today just going for a quick video trying to get the first print going on the Doppelbot, which is going to be the printer for the next large conveyor belt extractor. So this is pretty much showing the typical designer, and I'm doing a voiceover here. We're not actually on screen talking, we're sort of singing along to music, snacking, typical designer stuff. Do like to point out just about half hour for this entire process. I'm going to speed it up, get rid of the boring parts, just kind of walk through how things go. So for the attachment here, going very basic, we're just going to align the bearings and the lead screw mounts with the top of the rail and bolt them on. This helps because you're sort of hiding parts behind parts. That way you don't have to worry about the clearance above and below as much. So the first part, we're just designing around this. I'm designing to be inserted so that you'll slip around the rod. Just a slight catch on there so that if your screws do come loose, it won't fall off completely. It'll still be retained by the rod. That's maybe not super necessary, but it's always best to think about how this is going to be installed. If I just made a hole for the center, then I'd have to slide it on from the top or the bottom, which, especially with the lead screw, is extremely painful to slide past the nut. You have to take the nut off, put it back on. So it's kind of just the think about how the part is going to be used. These are, exceedingly simple designs, which is why it's not going to take a heck of a long to get through them. And the most important thing for this mount is that I know that the mount or the lead screw and the smooth rods are in a line. Had to verify this on my previous design. That's why I'm doing all this checking around, making darn sure that I have them actually lined up correctly. Always best to find things out like this beforehand. But once we get this in, prep it for printing, get that going. Typically how I work, just design it, ship it, send it right over to PrintShift, and wait for the parts to come out. So we're saving things to disk, getting it up into Prusa Slicer. Make sure we got everything. There's the printer. Upload to the printer, and good to go. Start printing. Printer was idle, so we threw it on the queue, and it's going immediately. We are going to interrupt this print, though, because I forgot to check reality. And we interrupt the time-lapse of that printing because the printer parts are upside down. Somewhere between designing and building this years ago, I put on the lead screws and the LMA LUU bearings upside down from how I modeled it in the first place. Can't tell you why, but doing a quick fix on these, going back through, editing the parts, making sure I don't have the chamfered screws, and reprinting. Did not get a time-lapse to the reprint. We'll throw it in later. Just a quick the state of the printer video, because I was recording a time-lapse of the construction on this, but that didn't work out, apparently. Sorry. But I have all attached. Hot end, the tool board. All the wiring is done. Belt's in place. As for our axes, we have X, Y, Z controls all 3 Z motors. So all 3 of these are hooked in series. I would like to eventually do 3 Z motors separate and then have these 2. There's a 2-stepper motor expansion board available for the Duet 5. But these 2 go down here, go to our 2 belt motors. So what's next for this printer is to get the electronics working and do a test print before we bother with getting the belt on. So I think the end of this video is going to be that test print, bit of things for the future, but let's go do some Duet config. Gonna sort of rush through things because I don't want, there's only a few of these Doppelbots in the world, But configuring the Duet firmware, some interest there. Alright, let's get started. Quick one on the RepRapFirmware configuration tool. Before you get started, if you're using this yourself, make sure you have your wiring diagrams. I have two wiring diagrams, one for the main, one for the toolboard. The same things I've been using to wire the printer, so these are true. Very important to know how your printer is wired. Alternately, you can get up and look at the wiring and come back, look at the wiring, come back, till you get bored and make yourself a wiring diagram. I always scan these in and keep them in the GitHub repo in case I ever lose them. Alright, so custom configuration. Duet 3 Mini 5 Plus. Firmware is the newest. I filled some of this out to test and apparently it remembered. Alright, that's fine. You can set mins and maxes. I'm keeping things relatively slow to start with. Add the toolboard. The address is pre-configured, which is nice. X is driver 0. XYZ bed for the 5 drivers. The X end stop pin is IO0. IO0 in, pull up. Pull up means that the IO will be high until the switch is pressed. So if you have an end stop wired between the in and the ground, when the switch is triggered, it goes to ground and pulls the signal down to low. So Y is the same one on IO1. So those are dumb switches. Z does not have an end stop, because the Z is going to be the probe. Don't know if I should configure an end stop for it. I think not. We might have to come fix this. Just going to run through the config for fan 0 is out 1. Print cooling fan is out 1. And the hot end cooling fan is out 2. I have that written. The heaters, the bed, output is out 0. Sensor is temp 0. The nozzle is the 121, out 0. And the sensor is thermistor. Hot end thermistor, temp 0. Nice when you have tools built well. And this can all be, the nice stuff about RepRapFirmware is all configured in G-code. So it's very easy to update later. This just generates your initial config so that you can change things and have everything you need to change versus having to write it from scratch. So the Z probe, the input pin, IO0.in is our BL Touch probe. The modulation pin, I don't believe we have a module. The PWM control is the IO0. So for BL Touch we have 4 pins. The IO0 out, ground, the IO0 in, and the 5 volt. X, Y, and Z are forwards. Steps per millimeter is 80. The Z, what are the steps per millimeter of the Z? I'm going to look at what kind of drivers I have on there. 8 millimeter lead screws, single start. So 2 millimeters per revolution. So 200 steps per revolution on the stepper motor, 1.8 degree stepper, and 1 revolution is a millimeter. Oh, that's really nice. It is a lead screw. 200 steps, 1600, set. Excellent. Max speed change. The Z is quite slow on these lead screws. You generally want a more than 2 millimeter, a 2 or a 4 start to go faster. Steps per millimeter is 420. 500 because I have experience with these. They have a crazy amount of torque, so we don't need to worry about it. End stop, which trigger height, eyeball on it. Generally want that too high, so that means the BL Touch will trigger when the nozzle is 2.5 millimeters above the bed. Heated bed will go bang bang because it's using an SSR. H0 is the bed, H1 turns on at 50 Celsius. I'm guessing that name's not used for anything important. Super sneaky, I know. So you could generate these all manually, and there's really nice documents on how to do it, but kind of nice if you don't have. Alright, let's look at a config real quick. All the configs are set as G-codes. So I could turn the printer on with no config and send it all these G-codes in sequence, and it would be configured just like this. If I want to change one of these, like if I want to change the maximum acceleration speeds, then I can actually change it in G-code on the fly whenever I want, update it, and if it's correct, come back and edit the config file so that it'll be correct on boot. GitHub. Is this what you want? And then there's quite a few different files for the, so we're not going to go through all of them, but the other important one is the config JSON. Just switch over to Firefox. This is what is used by the web config. So if you want to edit your configuration with a nice GUI, the same web config we just used, you can load this file up. Alright, I'm going to eject this, see if it works, and we'll get back to you. Probably gonna be a lot of little weird testing, so I'm not gonna record all of it, but you know, come on. Alright, about 6 hours later, config is in, done some tests. I've actually done a test print already, so we're not going to do the first print. Did a little rough benchy. So it's an interesting asymmetrical, good cooling on the back, bad cooling on the front. And I discovered that one of my cooling fans works, and the other does not. Alright, this is using a 0.8 nozzle, PLA at quite high temperatures, so the stringing is basically just not having retraction dialed in perfectly. Bit of dialing in to do with the machine, but on, running. One thing I forgot to do in the config video was tell the machine that it's a Core XY. A little obvious, but you do need to tell it. And also configure the belt axes. Did add the Duet module. Let's see if we can zero out the belt. Belt axis is the B axis. Why? B is for belts. Really good strength. Probably going to get some heat shrink to cover these rollers, get them some better grip. This is just PLA. Easy to replace. I think we do need spacers here. But, test print time lapse. Let's get it going. Control. Happy printing. I'll get this set up, go to the time lapse, do a little bit of a teaser at the end if you guys want to stick around. Daughter's telling me how to YouTube now. Let's see, where should we put the camera? Print's done. Looks pretty good. Kind of ringy. I want to talk about what's next for the channel, and of course, getting this bed on a priority, but also been in a couple beta groups for belt printers. That's the money shot. This is the Belty Jr., inexpensive little machine that was designed by Rob Mink. He was gracious enough to sell me one of the pre-print kits. I'm not quite sure what it's going to be, but with these two pictures of the machine, I did see it in person and examine it a little. We're going to see if we can put that together. How it goes. Basically, an extremely low-cost entry into belt printing. Try and get more people playing with these machines. It's going to be PLA only. I'd like to point out the built-in extruder. This, to me, looks like an inexpensive machine done right, where you have lower quality components. See the PTF tubes as bearings, but it's a small machine. It's also about the size of my hand. You can sort of see. 1-inch conduit for the rollers. All sorts of things that you can find easily and put together a reasonably well working 3D printer. I think cool enough that other folks will want to build her. If you're interested in this kind of thing, please like, subscribe, and if you want to see especially more beta printers or more expensive beta printers, please consider becoming a Patreon supporter. Throw all our names of our current supporters down here. Every dollar that goes to the Patreon goes towards buying 3D printer parts. And try to advance the state of 3D printing, not just belt printers, but 3D printers in general. Anyways, thanks for watching. Happy printing.